Hi there, grade 8. Let's have a look at question 5 of the March 2025 Free State paper. Okay, so let's get going. All right, so question 5, 5.1. Um, Write the following in exponential form. Okay, so let's just first have a look at exponential form, the word exponential form itself. Let's rather use a highlighter. Okay, exponential form. Okay, so write the following in exponential form. Let's first just discuss what that means. So exponents, it has a base with its power. Okay, so it has a base. Okay, so it needs a specific base, and that is usually something multiplied, whatever is being multiplied by itself, that is then the base. Okay, so we have our base, all right, and then we raise it to a specific power. Okay, all right, so it has a base and its power. For instance, a to the power of b. Okay, so that is an exponent. All right, so we need to write what they give us over here, okay, um, in exponential form. Okay, so we don't want to see the normal format of a specific number multiplied by itself a few times. We want to rather write this as only one base and a power. Now, we can write this in exponential form by writing our base, that is specifically the number that is being multiplied by itself. In this case, we have two bases, which is 5, because 5 is being multiplied by itself, and we have a base of x, and that is also being multiplied by itself. All right, so let's quickly rewrite this in exponential form. So, you ask yourself what number is being multiplied by itself, and then you say, listen, the number 5 is being multiplied by itself, so that is my base. And then your power is how many times is 5 being multiplied by itself? And the answer is, let's quickly count together. 1, 2, 3, 4. So 5 is being multiplied by itself 4 times. So 4 then makes up your power. So 5 to the power of 4 is then how we can rewrite 5 times 5 times 5 times 5. And then, guys, this is one thing that you actually struggle with. Remember, this is one term, okay? Because everything is being multiplied by one another, okay? So it's one term. So it should remain one term in your answer. So please, everything is being multiplied. So in your answer, you can either make a dot like that, which is a multiplication or indication of we're multiplying numbers with one another. Okay, or you can physically write a multiply. It doesn't matter. It's not either way would be correct. Okay, so our next base is x because we are multiplying x with itself. Okay, so my next base is going to be x, all right? And then you ask yourself, what would the power be for x? And then the answer for that is how many times is x multiplied by itself? 1, 2, 3. So x to the power of 3. Okay, and that is your final answer. And it's for 2 marks. It's two very extremely easy marks. So that is how you write um, numbers multiplied by itself into an easier format, which is called exponential form with a base and a power. Okay, so let's move on to question number 5.2. Okay, so they ask at question number 5.2, expand 3 to the power of 3, or 3 cubed, times x squared times y to the power of 4 from exponential to normal format. Okay, can you see we have a base and we have a power? we have a base of x and we have a power of 2. We have a base of y and we have a power of 4. So that is then currently written in its exponential form. But now they want us to do the opposite is what they asked in 5.1. They want us to go and write this in the normal format, which is then we go and multiply. We basically expand this as they state over here. So they want us to rewrite this from exponential form to the normal format. So let's do that. So let's start with our base of 3. Okay, so 3 cubed means we are multiplying 3 by itself 3 times. So that means 3 times 3 times 3. That is what that means, right? Okay, so now we have expanded 3 cubed. And then you write your times, which is in your question. So you write your times, and then you get to your base of x. Now, how many times do we multiply x by itself when we say x squared? 2 times. So we have to write x times x. Okay, perfect. That is then x squared. And then we write the multiply in the question itself. And then we work with our last base, which is the base of y. And we multiply y with itself 4 times. That is what the power tells me. So it's going to be y times y times y times y. Okay, that was very easy. That is all that you had to do to earn this 1 mark. Okay, perfect. So let's move on then to the next question, and that is question number 5.3. So let's read this question together. They say write 0,000000930 in scientific notation. Guys, now scientific notation is part of the chapter where you deal with exponents, and that is why it is in this question. This whole question has to do with exponents, and you need to go and study your laws of exponents, okay? So, or your exponential laws. Okay, so let's have a look at what does scientific notation mean? Okay, I want to explain all of the math concepts to you so that you understand what to do, because that is, in most cases, the problem. You read something, and you don't understand what scientific notation means, and then you cannot do anything further. So, scientific notation is where we use extremely, or where we rewrite um, extremely small numbers or very big numbers in an easier format without all of the zeros, right? If you think about billions and trillions, um, it has lots of zeros, right? We can write those numbers in an easier format for us instead of having all of the zeros or numbers behind it. The same thing, this is not a very big number. This is a decimal number. So this is basically a fraction, okay? But this is a very small number. Can you see all of the zeros after the decimal point? Okay, so that means it's a very small number. All right, so we can go and rewrite this very small number in an easier way without all of the zero decimal places, basically. Okay, so that is what scientific notation is all about. And there are specific rules when you do scientific notation. Okay. So the first rule that you have to apply with scientific notation is that you have to look for the first, after your decimal place, you have to look for your first non-zero number. In other words, your first number in this lineup after your decimal point. You have to look for your first number, which is not a zero. And your first number that is not a zero, right after your decimal point, would be the 9. Okay, so what you then do is you go ahead, you say, okay, you find your first number, your first non-zero number, that is 9. After that number, you have to write a comma. Okay, so then you write in your answer 9, comma 3. Okay, so that's your first step. Find your first non-zero number put a comma after it, and then write all your numbers after it, um, after that comma that you put in. Okay, and that is 9,3. You can also write 9,30. That's totally fine. But 9,3, 9,30, exact same value. All right. So then that's the first step that you do. The next step that you do is you write your multiply sign. Always multiply and always the base of 10. You will always multiply with the base of 10. Okay, so please, that's very it's as easy as that, okay? With a very small number, you go to the right of your decimal point. You'll search for your first non-zero number, which is the 9. Put your comma in there, and that is the first thing that you write. Okay. And then you always write multiply, and you always write the base of 10. Now, when we work with a decimal number, okay, a very small number in this case, your power will always be a negative, okay? Your power will always be a negative, guys, because we are going to move, we are going to shift our comma right back all the way to where it should be, okay? And we are moving from right to left. So when you work with a very small number, a decimal number, then your power would be negative. Or you can remember it that when you move your comma, from right to left, okay? From right to left, where you put the comma in to where the comma originally was, then you would have a negative power. And now to get the actual number of your power, you just count your number of decimal places from the comma that you put in to the original comma in this decimal number. So let's count the number of places together. That would be, okay, let's use a different color to, let's make it obvious. Okay, let's use sky blue. Okay, so we would say, cool. 1, 2, 3, 4, 5, and 6. So can you see we are going to have to shift this comma that we put in manually 6 places to the left. Okay. And as soon as we move to the left, shift the comma to the left, we're going to have a negative power in our scientific notation. And how many places did we move to the left? We moved 6 places to the left. So this is my final answer. So I can, guys, this is the exact same value. So the value of this and the value of this is the exact same value. You would even see that your scientific calculators, when a number is extremely big or very small, they also give you the answers in scientific notation because there's not enough space on the screen of your calculator to add all of the numbers, all of the zeros, okay? So your calculator also gives you answers in scientific notation, okay, when they are very big or very small numbers, okay? So these are equivalent. That means they have the exact same value. We just rewrite it from this format to this format. Can you see this looks easier? It looks much more workable than we have this. Imagine writing about decimal places that has much more than this in research, and you have to write the decimal number the whole time. It would be much easier to write the scientific notation form of it. Okay, so that is the answer for these 2 marks. Okay, let's just go back to our color that we had, and then we can move on to 5.4. Okay, let's just get rid of that. Now we can move on to number 5.4. Okay, so over here, we're just going to have to make a small adjustment to answer this one. So they say write 1,94. So this is my decimal number or decimal fraction times 10 to the power of 4 as a decimal fraction. Okay, guys, so this is not necessarily going to be, the answer of this is not going to be a decimal fraction. So this is the only part that might have been a bit confusing. But guys, if you can just apply what they ask you over here, you will get to the answer. Okay, so can you see that this is written in scientific notation? Because we have a decimal number or a decimal fraction times the base of 10 to a power. So this is written in scientific notation. Okay, but can you see our power? Our power over here is a positive power. This means that this is actually a big number and not a small number that we write as in an easier format. But now they're asking the opposite. Okay, so let's expand the scientific notation to get the original number. Okay, and all you have to do is you just multiply with 10 to the power of 4. Okay, so can you see when our power is positive, we are moving to the right. Okay, so it's the opposite as what we did in 5.3. When our scientific notation is negative, we will be moving to the left. When our scientific notation, when the base of 10's power is positive, we'll be moving to the right. So you just write your decimal fraction, your decimal number, 1,94, and then it tells you to move your decimal 4 places, guys. This is what your power tells you in scientific notation. Move your decimal place 4 places to the right. Okay, so that's what we're going to do. We're going to say 1, 2, 3, and 4. Okay, so my new decimal will be there. Okay, so now all you do is you erase the comma because you moved your comma. Sorry, there was actually, let's just quickly put that back. Okay, so you would see the first thing that you do is in these little brackets over here or this little hoops over here, the spaces that you create, when there are nothing in there, you have to put a 0 and a 0 in there. Okay, do you understand that? If there aren't any numbers due to your decimals already in there, you have to put zeros in there. Okay, and then after you've put your zeros in, you can go and erase because we've shifted our decimal place to there, okay, to its new place. But can you see that this is just going to be comma 0 in any case? Do you understand? That is why it's not going to be a decimal fraction necessarily, but it would be correct if you say comma 0, or it would just be correct by saying 19,400 is your final answer. Okay, so perfect. That was for 1 mark, nice and easy. Okay, then we get to 5.5. Now, this is very important because we apply these principles up until grade 12, not the same calculation, but the principles that we use here, the the laws of exponents um, are very important, okay, up until grade 12. So let's quickly focus on what we have to do over here. So the first thing, guys, I focus a lot on you knowing that how that the number of terms is very important, okay? Let's first discuss how many terms do we have in this expression over here. Okay, so 3a squared b, okay, times negative 2ab cubed. Okay, so this is one term, guys. Why? Why is this whole thing over here? It's one term. Why? Guys, let me just, okay, it's one term, okay? Because can you see we are multiplying two expressions with one another? The one is a positive expression and the other one is a negative expression. That minus over there does not separate your terms over here. Okay, because you are multiplying one expression, you are multiplying this expression, 3a squared b, with negative 2ab cubed. Do you understand? Okay, so the multiply combines terms. So this is one term. All right, that is the first thing that you need to understand. Okay, let's just, that was not part of the question. I just want you to figure that out. Okay, or to realize that. Now, the first thing that you do when you multiply two algebraic expressions with one another is you first deal with the numbers. Okay, you first deal with the coefficients basically. Okay, the numbers. So you first say 3 in this expression, okay, times the negative 2 in the other expression. So you first deal with your numbers. So let's say 3. What is the answer for 3 times negative 2? A positive times a negative will give me a negative. 3 times 2 is 6. Okay, so there we have dealt with the numbers in the two expressions. Okay, and then after that, you deal with your different bases, your different variables. Okay, so we have two variables. We have a variable or an unknown of A and A in both expressions, and we have the variable of B and B in both expressions. So you deal with each variable individually. So let's first work with the variable A. Okay, so we are going to now work with, let's just use different colors to make this easier. We are going to work with the variable A in this expression and the variable A in this expression. So what are we doing with these two bases, basically? We are multiplying A squared with A. Okay, look here. We are multiplying A squared with A. We are still multiplying it, okay? So now your laws of exponents needs to kick in, right? So when I multiply the same base, because remember A and A is the same base. When I multiply the same base, I need to add my exponents. But what I have to remember though is that when I just have a variable itself, that it's to the power of 1. Okay, so remember to write that 1, especially in grade 8. Write that 1 that reminds you that it's a to the power of 1. Okay, so now we are multiplying a squared times a to the power of 1. So then you write your base of a that you are working with. Okay, and then what do we say? What is the law of exponent that's applicable here? When I multiply the same base, I need to add my exponents or my powers. So I say 2 plus 1. Okay, so I add the 2 of the first base of A plus the 1 of the other base of A. Okay, cool. Let's get a new color because we are done with the base of A. Now we have to work with the base of B, okay, in both expressions. Once again, I'm going to be multiplying the same base of B. Okay, so the rule says when I multiply the same base, I need to add my exponents. I need to add the powers, okay? I need to add the exponents. So therefore, remember, once again, this is just the B. So it's actually B to the power of 1. So we have to remember that when we write, you only write your base once in your answer because multiplying your bases, you just add your exponents. You add your powers. Okay, do you understand? There we go. So now your final answer would be negative 6 a to the power of, let's just quickly fix that. Okay, a to the power of 3, okay, and b to the power of 1 plus 3, which is 4. And that is then your final answer. Okay, so that is how you deal with multiplying two algebraic expressions with one another. Okay, perfect. So that was 2 marks. And then this question, question 5, the last question of the March 2025 paper, counted only 8 marks, and that would have given you the total of 50 marks for this paper.